A square pyramid of 35 mm sides of base and 60 mm axis length rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and to VP at 30 degrees. So this is the problem. So here, since he says axis rests on HP on one of its corners of the base, since it is resting on HP, so obviously we have to start from HP. So we have started from HP, that is from the top view. So here, the resting on one of its corners of the base, two base edges containing the corner makes equal inclination. So in the initial position also, when you are considering the two base edges which is resting on HP, the corner which is resting on HP, the two base edges containing the corner which is resting on HP makes equal inclination. So in the initial position also we have to consider like that. So how? If you consider any point, you can consider any point from here. If you draw a line and also if you draw a line here, so these two edges, that is AB and AD, must make equal inclinations. That means with respect to this vertical line, this has to make equal inclination. In this case, since it is a square, this will also make an angle of 45 degree and this side also will going to make an angle of 45 degree when you look from the top view. So that we can evident, you can see here also from here, this angle makes an angle of 45 and from this side also it makes an angle of 45 degree. Suppose if it is resting on A dash. Suppose if it is resting on C dash also, this also will make the same angle with reference to this. So that is the meaning of the two base edges contained in the corner on which it makes equal inclinations with HP. So now, since all the base edges are resting on HP, so obviously that becomes parallel to HP. Since it is parallel to HP, I can see the true shape in HP. So you can see the true shape in HP. That is when you look from the top view. Now when you look from the front view, I can see the height of the pyramid. So the height of the pyramid is 60 mm. So this height can be seen here on vertical plane when it is projected onto the vertical plane. So this is the height. So since when you want to draw the front view, A, B, C is near to the observer, so A dash, B dash, C dash is visible. And when you look from the front view, D is away from the observer, so D dash becomes invisible. So here you have a triangular face. OAB is one triangular face, OBC is the another triangular face, OCD is the another triangular face, and ODA is the fourth triangular face. So you have four triangular faces for a square pyramid, and we have similarly four slant edges. One is OA, OB, OC and OD. So now we need to, so this is the initial position of the object when you look in 3 dimension. So this shaded portion what we have shown is the opaque surface. So when you look from the front view, this OD becomes invisible. So obviously that OD will be invisible. So it will going to be a dotted line. So that, but the preference when you look from the front view, OB is visible. So OD will not be shown here, but you have to show the notations so that D dash will be in bracket. And similarly, O1 dash will be in bracket because AB, BC edge will going to hide that particular O1. So O1 dash will be in bracket. So now we have to write the sketch here. So first you consider any point, then by using the protractor, you take that protractor in such a manner that you will be able to see 45 degree on this side and also 45 on this side. So that means from here to here a measure angle of 45 degree with respect to vertical, and from here also you measure 45 degree with respect to the vertical, and then draw this line and this line. By using the compass, you measure a radius of 35 mm with A center, cut an arc on this line to get the point B. Similarly, from here you cut an arc on this side to get the point D. Then from here you again draw an arc of radius 35 mm by using the compass. From D also with the same radius you cut an arc on this to get this point C. Then draw AB, BC, CD and DA. Then draw the diagonals also with the dot line. So O is near to the observer, so it is visible. O1 is away from the observer when you look from the top view. So O1 is in bracket, so that O1 will be in bracket. When you look from the front view, I can see the height. So first now you write the front view for this. So you project all project the vertical projectors, all the vertices, draw a vertical projector from all the endpoints to the xy line. So you are going to get a dash when you look from the front view. A, B, C is near to the observer, so a dash, B dash, C dash is visible, and D dash is away from the observer, it is invisible, and O1 dash is invisible because AB, BC edge will going to hide this, so O1 dash will becomes invisible. Then you measure the height of 60 mm from this and you mark this point O dash. Then O dash is a visible edge. When you look from the front view, OE becomes visible. So that is the extreme point, which is the apex point. So then join O dash to A dash, visible to visible is visible. O dash to B dash, visible to visible is visible. O dash to C dash, visible to visible is visible. Then join between A dash, B dash, again visible to visible is visible. B dash to C dash, again visible to visible is visible. So you are going to get the triangle. So now, since the axis of the pyramid is inclined to HP, so here what will going to happen? The axis is parallel to VP. Since the axis is parallel to VP, so I am getting the true length here, O dash, O1 dash. So that axis is inclined to HP at 40 degrees. Now, here, since it is resting on one of the corners, so you make that A dash on XY line. Since the axis is inclined at 40 degrees to HP, so we will going to make the base to inclined at 50 degrees. So consider any point on the XY line, and then by using the protractor you measure an angle of 50 degree here with respect to XY line, and then you draw a line. Then you measure the length from A dash to C dash. From A dash you cut an arc on this to get this point C dash. Similarly, measure the length from A dash to B dash from the compass. By using the compass, from A dash you cut an arc on this to get this point B dash, D dash and O1 dash. You name them. So from B dash you have a vertical line which is perpendicular to A dash, C dash. So by using the protractor you measure an angle of 90 degree with respect to that inclined line A dash, C dash, and then draw a perpendicular line to A dash, C dash. Then you measure the length from B dash to O dash. From B dash you cut an arc on this to get this point O dash. Then complete this sketch exactly in the similar manner, exactly the same as that of the first position front view. So now we need to write the top view. Since we need to write the top view, so draw a vertical projector from O dash and draw a horizontal projector from O to get this point O. Draw a vertical projector from A dash and draw a horizontal projector from A to get this point A. And draw a vertical projector from C dash and draw a horizontal projector from C to get this point C. Similarly, draw a vertical projector from B dash, D dash and O1 dash, and draw a horizontal projector from B to get this point B, and draw a horizontal projector from D to get this point B. Then O1 is already projected till here, so you are going to get this point O1. Now we have to join them with a thin lines, continuous thin lines. So you join between A to B, B to C, C to D and D to A with continuous thin lines. Then join between OA, then OB, then OC, then OD. So now we will apply the condition of visibility. All the exterior edges of the boundaries of the solids are visible. So we can see OB, BC, CD and DO. All the edges is on the boundary. So naturally that becomes visible. So you dark them. OB you dark, BC, CD, DO dark. So then when you look from the top view, O dash, C dash is the slanted which is near to the observer. So that will be visible. So dark between O to C, which is a continuous dark line. So then if you see that OC is visible, now when you look from the top view, so we can see the triangular face OCD, the triangular face OCD and OCB are visible and OCB are visible. So since this OA is the edge, now since OA is the edge, when you look from the top view that becomes invisible, but we always have to give the priority to the visible edge, so you darken this OC. Now here, since A becomes invisible, so when the edge or corner which becomes invisible, so but we cannot show that because it is that OC is hiding that edge, that this OC line is hiding this edge OA, so we cannot show that because that is exactly below this OC. So now that is not visible. But since OA is an invisible edge, so from the point A, there are three edges which is coming out. One is OA and the other one is AB and AD. So what happens to, since OA is invisible, so naturally AB and AD will going to becomes invisible. Since portion of this ABCD is invisible, that is AB and AD, so naturally O1 will become invisible. So you make a use it in bracket.